So we can see this is the result. Now the bottom, I wanted to show you I didn't use supports because I didn't realize that I should have. And you can see that it did not, because it didn't have anything to adhere to, so it's very poor quality on the bottom. But look at how amazing the top is. See, that's kind of when it had more support. Of course, it's not perfect. This side was like dangling up, was like angling up, and it just kept tapping into it. You can see that, just that degradation there, but the rest of it's really nice. I can sand all of that out. That's perfect. It's fairly nice and thick. Honestly, I think I made it too thick because I didn't know how to measure this. This is the first, I didn't use proper measurement when making this. I just kind of, you know, generalized it, but it's a really nice result. Like, this is really, it feels like I'm started squishing apple. It's really tough, I guess, because it's really thick. But yeah, obviously use supports and make it a little thinner probably, but look at how lovely that is. I can put a motor on that. I'll do a water test to see if it floats. Okay, we're in the bathtub and I gave it just a little bit of a basic sand. As you can see, it's a little better. I definitely do a better job. But for now, does it float? Oh, it does. Oh, it floats. Nice. I don't know if you can. It's kind of hard because it's the red, but look at that. See? Oh, and if we get some water in, how much water does it take to sink it? Ooh, honestly, it's pretty darn buoyant. I think it's like got semi hollow in there. Here, it's actually, it like doesn't want to sink. Here, I'll get my water. Yeah, look at that. Even upside down, man, that's a good design. You see, it does not want to sink. But if I put pressure on it, it may, you know, if I put weight on it, for example, it'll, you know, see, it needs, so it's actually, but admittedly, considering its weight, it's like 30 grams or something. So here is the manufacturing of the boat. Now, of course, there were some errors that I faced because alright, so pretty much we have two batteries, two AAA 1.5 volt, we have a switch, we have a 3 volt blue LED, some cables, and of course a motor, which, you know, you can pretty much run on anything below probably around 9 volts, give or take. You know, it's about a 3 volt motor, right? And my idea was to put everything in series. Now, obviously, that's not going to work because it's only 3 volts for the light, and then the motor's not going to get anything. So it's one's going to run or the other's going to run. Then I tried to do parallel, and apparently that actually didn't work either. So anyway, let's go through it. So I'm just desoldering these wires because I want to use thicker ones. Here you can see I'm hot gluing the batteries to the boat. As you can see there, I'm hot gluing the motor to the boat, and I hot glued the light. My first idea was just to try to get everything in position, which was probably not the smartest idea because when you're working with batteries, they're a bit of a pain in the butt to solder stuff to. So it's actually probably easier to solder them out. But honestly, it wouldn't have been any easier to do it the opposite way. So here we are, I'm just working out the switch, preparing the wires. 10 minutes of wire cutting. Wow. Poor me. So here, as you can see, I'll try to go back a little. I'm preparing the switch. Did it completely off camera, excuse that. Pretty much what I'm doing is just twisting wire. Is there a view in there? You can kind of see it off to the side there. I'm twisting wire into the connectors. You know, pretty obvious stuff. And then I solder it here, and then I hot glue it to make sure that it does not short circuit. Now, funny thing, these switches are pretty weak, and it turns out I melted 2 of them. So yeah, basically broke 2 switches. Not fun. Just pre-soldering wires, which is good. And it looks like here I'm soldering the motor to the batteries, or just not quite yet. So here I'm trying to get the motor to the battery, and there I've got one. Here I'll try to go back. This is a pain in the butt to do this part. Here we are, soldering the second wire. Pretty simple stuff. And now I'm trying to solder the switch to the light, as you can see there, and the switch to the negative of the battery. And there you can see I've got it all wired up. And then finally I test some cable here. Well, I solder it first. Actually, you can see it's onto the positive of that battery. And firstly, it doesn't really work all that well. You can see down there, I actually put a little piece of plastic on the motor to act as a spinner. For some reason, the light would turn on when I would push the button in, and then I figured out the button's broken. And the motor wouldn't turn on. So anyway, let's go to part 2. Okay, now part 2, I am chopping some parts off because I realized, oh wait, you can't put 3 volt LED and a 3 volt motor in series because it's 3 plus 3 equals 6. You need 6 volts. I don't actually understand how you'd work this out with the motor, because the motors are very variable in how much they use, but I imagine if you had 6 volts, 3 would go to the light and it wouldn't short circuit, and then you would have 3 going to the motor. Of course, I didn't really think about that, but you know, if I ever wanted to do this, I'd probably use 2 different circuits, a light switch circuit and a motor circuit, maybe. I don't know. So here I'm just rewiring it in parallel. You can see I had a bit of trouble, let's just put it that way. Getting these wires to stick onto the batteries was a pain in the butt. If you don't have a what do you call them? Those little strip welders which send a little zap, and then they just, yeah, here we go. So it's there, it's connected. Do I show it working? And I try to get the light on, and you can see, like, when I switch it off, when I switch the circuit off, the light goes on. When I switch this there, and then when I switch it on, you see down there, the motor starts spinning. So it's like an off, it's like an on or on. It's either do you want the light on or do you want the motor on, which is actually kind of cool, but I'd burn out the battery, so my understanding of electronics is not good enough to understand that. I just said, okay, never mind about that light. We'll just, you know, just leave it be. So we have a bunch of water. How good are those acoustics with the water in the room? Wow. I think recording with water would be really cool. It sounds like I'm in a cave or something. Firstly, does it float with all of the new electronics? Yes, it does. That's so cool. It's kind of angled. I don't know if you can see that. So it's just like if I push it over the edge. Oh no! Oh no! I think it might be too, technically it's waterproof. I'll make it a little bit smaller, or it's too quick, I think. I assume the angle obviously doesn't help. The reason why I had to use that angle was because, well, putting a small cheap motor underwater is probably not the best idea. Let's test it out. Oh, it's a little more stable. It's a tiny bit more stable. Yeah, it just seems maybe too quick, I don't know. Maybe the direction's off as well. Oh no, it's not working anymore. Oh no, I think I'm... Oh shit. Oh, there we go. Extra fast now. Well, that sucks. Maybe instead I could do my first idea of just having lights on it. It doesn't float now. Oh well. So I think if I made it a fair bit bigger for that motor, it'd actually work pretty well. And then if I got the angle more correct, it'd probably, you know, probably work. But I can't really be bothered doing that right now, so I'll just leave it there. So first thing, you get a 3D printer, and of course, what do? You look up anime models online. Which kinds? Well, I mean, come on, let's be obvious. And you click all these things, and then what happens is that, so it turns out in this absolute sea of arse, it actually costs you money download these. I thought this would just be a free, like a candy shop of just free models. But it turns out that people figured you can make money off these things. And if you want free 3D printed models, it's actually not, well, it's not that easy. You can get some, but the ones you want, they're gonna cost you. And of course, the logical conclusion, to save $20, you can learn to make your own through Blender. Of course, Blender's a massive pain in the ass to use and to learn. I don't know if it was intentionally made as a massive pain in the ass, or it just has a really annoying learning curve, but that's been my experience. But alas, I have been putting in some work. So anyway, if we, for example, turn on the grid like that, and then we move this cube around, we can see it's moving in these little grid patterns, which is nice, because for making technical things, that's kind of really what you want. And of course, each of these grids is a centimeter by a centimeter, and each of these small ones is a millimeter by a millimeter. At least that's if you 10x it. When you export, that's what you get. So I've been working with this, and I've found, if I turn on the see-through thing, go to modeling, select my objects, edit, here we go. If you use this thing, what is it called? The viewport, I think. You can see like X, Y, Z thingos. It makes it really easy for like precise editing. And then of course, if we go see-through, select all the top ones like that, back to X, we go, and then we move it. The hotkey is G. We can see it snaps, and then we click something like X. We go G and move it on the X axis. I think, did I screw that up? No. And we go G, move it on the Y. It's kind of, we'll move it on the Z. That's what I wanted. I want to move it on to Z. Then I can now make, like, that is a 2mm by 2mm plane. Isn't that nice, And then if you want to use either loop cut to start adding lines like so, there we go, or you want to use a knife tool or whatever, now we can start, for example, if we click faces, you can start, oops, excuse me, let me fix that up. Whatever, instead, we just go like this, select all the top ones, except for these. We don't want those. Actually, we do want these. We want some of these. And then we just extrude it up with E. Now we've got kind of some form of box, for example. Of course, this is, you'd want to, oops. Well, now we've got who knows what that shape is. You'd kind of want to thin it down, thin these edges down, of course. But, of course, you could use you could do that again, and then you could, select all these faces and lower them if you wanted. Yeah, let's just go back to this. We do it that way, it'll look like this. It's kind of cool, actually. Or if we do the extrude, I gotta see what I'm doing, then it'll look like, well, that's not what I wanted, but you get the point. You can thin it down. Of course, you would have done that earlier. Point being that this is kind of a way to make precise stuff, right? And if we want to add a different shape, of course, unfortunately, this isn't some pretty model, but it's not really what it's meant to be. It's good enough as a it's more engineering type stuff. So we get that back down. I think 5 maybe. What's that? Like half a centimeter. It's a wheel, right? It's a wheel. Isn't that nice? We could try to get something in the middle, get rid of the middle area, and make it so it is actually a wheel. But just as I said, I didn't say, but basic geometry, right? You make stuff out of basic geometry. This is an example. This is before I really understand the measurement and the snapping tool and all that, but here is a basic gear. I haven't printed this out to test out if it actually works at all, but it's nice in theory, maybe, I don't know. And I also forgot this is before I understood measurement, so this would technically be 2 centimeters long, which is pretty small, but you could make it bigger if you wanted to. Here was another thing, which is my little boat, which I made from a box that I flattened out. As you can see, flattened it out, and then I pulled these vertices together, and then I just curved it all out, and I extruded or pulled up the edges, and then we made this little boat. And of course you saw, or you will see, this little boat in action. Alright, so this is me making a AAA battery case, which is small batteries for 2 of them, right? It's a torch case, so it's going to have a switch, a light, 2 batteries, and yeah, just like that. I went through a bunch of different designs for this. I think I went through like 3 major changes, and then I also had about 3 earlier ones which had a different kind of design, which I don't know, maybe you'll see, maybe you won't, just like a simple box with a hand or the wool on it. Anyway, going on, so let's get into it, right? What I'm doing is I'm measuring batteries, of course, and I'm measuring the switches to get the length, the width, and the height, because if you can understand that and have a geometrical model of the dimensions, and of course working with square-based objects is easier. A circular object essentially you can imagine as a square, because of course it has a length, but its width and it has a, depending on how you want to look at things, the height and the width would be the same, or we'll just say the length is like the longest part, we'll just say. So it'll have a length, but then its width and height should be the same because it's a circular object, right? So the batteries were, if I have my measurements, the AAAs for me were about 44 millimeters in length, and we're working with millimeters, of course, and they were about 10 millimeters in width. But the thing I did is that I made them an extra millimeter. I made everything pretty much an extra millimeter longer to fit it easier, because of course a 3D printer isn't perfect. So if you don't want to be filing things away, which you can do if you want, but I couldn't really be bothered. So here I am making it longer. Of course, here it's 2 millimeters thick, which once you get into 1 millimeter, 1 millimeter is a little bit thin. You can do it on the 3D printer, but it's a bit thin where you start going into, if there's any errors with your print, it's going to be bad. And there's certain parts of it are just going to they're just going to break, and it's not going to be good. 2 millimeters is a really nice, easy medium. And you can see here I'm putting the edges on the case, because the case is the internal space of the battery, which will go here, and then it's the external space of the actual case, of the actual solid plastic, which is what I'm doing here. Now I'm extending it because I want my switch and just my wires and all that to have a little bit of space, but pretty much because the battery is 44 long, but I do it 45. This is about, you can see here, each of these blocks is 1 centimeter or 10 millimeters. So we got nearly 1, 2, 3, 4, 5, 6, nearly 7 long. And right here I've got all these edges and all the empty space worked out. So I'm basically I'm extruding up here. which extruding it kind of makes you see how it's got a line, otherwise if it wasn't it would just be dragged. And then I'm making the extra part, you know, for the lid where that'd go, because again, so you can think this block is like the space and the others are the outer spaces. So we have a little, you know, looks like a little coffin or something, right? And this is the basic design. Then eventually I put these all these other lines, and you see this here. I have the battery separator, and then eventually we put in the back of the battery. Now this is too small, as you know, I needed more space for the batteries to go, because I had to put my electronic connectors there, which I fixed later on. And now I'm opening up this area. I don't know how to do it very well. It's a bit of a pain in the butt in Blender. I kind of figured out a new way you can use with it's called the special modifier. But oh my goodness, it's CAD work with Blender. So annoying. So look at all this. This is just frustration. Because I don't know how to do it properly. I mean, maybe there's a good way to do it, but I don't really understand. Anyway, here I am. I made a cube, and all I'm doing is I'm making a lid with the cube. You know, pretty easy, pretty simple stuff, right? So you can see it off there. That is the lid of the cube. And now I'm making, because what my idea was to make a slide lid or a slide door, because either I could make like a slide lid or door, or I could make a clip on it. You know that when you put like a television remote and just go click, they would be nice. But the issue with that is I have an issue, or at least I had an issue here getting negative space with Blender, just because, you know, I couldn't really, it was more of an issue of translating my thoughts to the software. Anyway, I'm just working on it here. You can see I've popped these two up. Jeez, it took me way too long to do that. And you can see it's got a hole. Yeah, it's got that hole for the thing. Anyway, now I've extruded this over, and you can see now it's got that little slide door. And now you can see I've kind of took me a little bit here. I've done this so that it can slip under and still kind of, you know, be smooth on top, right? So anyway, let's look at. So what I had to do is I had to fix the normals, which is this blue thing. And then I had to use this 3D printing tool. You can see it on the side. You have to install it and press N, and you just do check all, and then you just click the distorted, and it fixes things. It fixes issues, you know, 3D printing issues. See here, I've got it in Ultimaker Cura, and I'm slicing it. I played around a lot with different settings, different temperatures. I settled on 60 degrees base for starting, then 50, and I settled on 1.6 millimeters for the base thingo. I used zigzag supports, and I found printing the first layer too slow is not good. 60 ms seems to work just fine, but you know, having more issues, yeah, not fun. I found out that you have to use the glue stick, or else it just does not work well. So you can see the two ones there. It's printing, very nice. It's printing, getting a little bit higher. You can see here, that one was very warped, unfortunately. That was my first test, and there it is, all nice and done. Well, besides horrible warping in the corner. Yeah, I don't really know why that happened. I really don't know, because temperature was there, the glue was there. I was just having a terrible time. It was a Mercury retrograde. It's just not fun at all. Now I've taken off all the supports, and you can see it looks pretty nice, besides the warping and some defects. The batteries fit, and of course there isn't much give room. And the switch fits, which is nice, right? But the case does not fit. It is too tight. So of course what I do is I go back to the editor and I extend the distance between the slide these areas here, sadly I don't really have a good view of it, whatever. And then I had to refix it. You see how you can't see this edge here? I had to fix it again. It's a nightmare, but here we go, we got it all nice and fixed. Now, it also turns out that I put it needed more support here. You can see these bottom parts, these kind of, I don't know what you call a bracket. I put those in again, and that was my 1, 2, 3, 4. Okay, so actually I did this 4 times. This specific design. Printing. Okay, this is design number 2. See here, I've taken off the thingos, and this one, it actually, here we go. Look at this. It actually slips in. You could grease it if you wanted to make it a little more easy, but it's fine being a bit tight. And the issue, as I said, is that I could push down on it and it would kind of push in, and it just wasn't secure enough. You see, these are some of my earlier designs. I just had these like boxes here, and that's a 1mm by 1mm. That's a 3mm one. With that battery stuck in, and now I still have to pry that out. So the box design didn't really, that would have been a pain in the butt to solder. So, and it looks like here, this is the one with these little brackets there. Look at that. Look at that. That is, and look at the bottom. It's a little warped. It is a little warped, but it's mostly, it's 95% good, right? Alright, so here's me putting together the first one. Now, long story short, this one did work, but it wasn't what I wanted. It wasn't I wasn't able to get the batteries in and out because it wasn't long enough. So my connectors, I just couldn't really put good connectors there. But alas, it did, functionally, I did get it working. So 3 volt blue LED, 2 1.5 volt AAA batteries, some wire, a switch, and the box and solder. Obviously this is all in series, as you would imagine. So here, of course, one thing, I also drilled a 5mm hole here. Later on in my design, I add a hole. Of course, the hole's still too small, even though it's 5mm. It's just, printing errors. I guess, as I said, make everything 1mm larger. As you can see here, I have to force that battery in, so that's an issue with the design. And the connector for the LED was just, I make these little, you can see here, I just curl the wire, and that works, mostly fine. It's not a great connector, but and then here I just basically have to solder wires onto the batteries. You can see here I'm just soldering wires. It's soldering wires. What I had to do was I had to melt part of the case. You see here, I gotta melt it because it just doesn't have enough space, doesn't have enough connection. Here I'm soldering on the switch now. Then I hot glue it to prevent, as you see here, any short circuiting. If you want epoxy, you want a resin, you want a hot glue. There's different. You can buy this paste. I think it's like a urethane paste or something in like a tube or a tin or a can or something in a little paintbrush online. If you look it up, to just coat your electronics and just prevent short circuiting. It's not a bad idea. Here I'm soldering up the wires of the battery. Got them both in. Unfortunately, it's off camera. I'm sorry about that. And there you can kind of see it there, and it works. It does work. Just make sure it's good. I melted the absolute crap off the case. It still worked. Like the sliding door still worked, but you can see here I'm trying to, because I've just melted so much of it, it's trying to get it on. And I'm hot gluing the batteries in, which is what I didn't want to do, just to keep it, oh, here we go, because as I said, I wanted them to be removable, which we didn't. So we can see here, I can kind of force that door in, and it's a flashlight, right? Or torch. Now here I show I'm hitting it against the ground, not too hard, but I'm showing that it, the hot gluing of course works. The electronics are not short circuiting. They're not, breaking. They're not. It functionally it works. 2mm is thick enough, and all that stuff. You can put some padding in the middle of it if you need to, but otherwise it works. So of course here I am putting a hole in there, which as I said is about 1mm off. I still had to use the 5mm drill to drill it, and now I am wiring the second fully wired one up. We're using a white LED, similar ideas, just coiling it. So here I have, let me go back, coiling it up, and eventually I actually put some foil in there just because the connection just wasn't good enough. And so I'm using foil to make connectors for you see here, this is where the battery and it connects to the switch. Sorry, it's a little bit blurry. You see there I'm testing it out, making sure that it's tight enough, because all I do is I hot glue that there. Now long story short, it didn't work because it's really hard to get solder attached to foil, and I thought maybe I could sandpaper it, or maybe I'd probably have to tie things together, but I really didn't want to. So in the end I ended up kind of getting rid of it, but I put it over some wire. So yeah, I'm just hot gluing it all together. Yeah, as I said, I remove those eventually. Testing the batteries out. I'm preparing the switch again. Connect them, hot glue them. You know how it works now. And I'm trying to get some pre-solder on there. Does not want to work. Does not want to solder. Trying to solder the cables, does not want to work. I'm just melting my box and it's not very nice. So eventually I just rip them off. And then what I do is I kind of fold the wires over and then just hot glue it all to keep it in place. It's pretty messy. It's pretty messy right now. So the wires are acting as a connector, but it's not. Like it works. You can see here, I'll put in a battery. It kind of works, but I have to push it, which is not good enough. So what I do is I put some foil over the top of it, just to give it some like conductive buffer. And then of course I hot glue them on the top, not on the not where the metal is, because then I'd break the connection. And of course I hot glue in between them to prevent short circuiting. And it still wasn't enough, still wasn't tight enough. So then I put some foil on the light, the LED. Right there, see there where the LED is up there. So now all the connectors are forward. Now this is kind of not the best because it's hanging over nearly out of the box, but it functions. And I hot glue this hot. And it's a little bit difficult to get the lid on, but it does work, it does. And there we are. Look at that. Look at that. Oh, my hands are all gluey and partially burnt. Anyway, we now have a removable battery light switch that's 3D printed and then just whipped up with some AliExpress electricals and just some batteries that you get from the supermarket, right? I think I pull out the batteries just to show you that pulling out the batteries to show you that you can pull them out and then you can put them back in. This is exactly what we want. Very nice, right? Less melted than the first, a little bit. The printer I use is a Elegoo Neptune Pro 4. Would I recommend it? No. I want to, but I can't, because it's a glaring issue, which is that you have to go through a really difficult or annoying process to update it. You literally have to connect it to your router, find the IP address through the router or through some other thing, and then you have to SSH into it, the program called PuTTY, and then you have to use these commands to forcefully update it. And while you have you have to download these files, and this isn't really explicitly told and how to do it. You have to go through a bunch of different Reddit threads where people are trying to figure this stuff out. And why hasn't the company just updated them? Do they not want to pull open all the boxes and have to do that? It's just pure negligence. So it's hard for me to recommend this one. I've had a million other issues with it. It's just I don't know, maybe it's just 3D printing itself is just a pain in the ass, thickness of lines, heating, getting adherence, warping. It's an absolute nightmare. Of course it is Mercury retrograde, so but I really wanted to give you my honest opinion on it. I didn't want you to be like, oh yeah, you got this one, so I'm going to get that one as well. Maybe look around, maybe look for some different reviews. Unless you're willing to go through the awful process of updating it, you're really technologically advanced and you know what SSHing is and how to do that. It's like directly accessing something through your router. Bloody nonsense it is. Otherwise, it works. The printer works now. It works, reasonably good. It's still, as I said, I'm still kind of getting through some issues to get really, 99% good prints. But we are getting there. We are really getting there. I hope. So, but otherwise, it's been a nightmare to get there, and I wanted to be honest about that. Otherwise, I had a lot of fun. I've really been enjoying this, and I really want to keep doing a bunch of this stuff, just to, play around with engineering. At the end of the day, I think if you can make something in a small version of something, you can probably make a big version of something. Will I? Won't I? I don't know. Maybe one time in my life when I have the resources and the time. Of course, for now, I can just play around. It's like a little slave workshop in my own room. I don't know. I feel like Santa Claus making, and the elf is my printer on my computer, software and all that. And I'm just making all these kind of crazy toys. It's a lot of fun. If you're interested in 3D printing, it's pretty. I'm not going to say it's cheap, but it's fairly cheap. I got this one for about a bit over $300. It was on sale, and I did get a discount and all that. But you can pick up a print for even I think $250, $300. And if American currency, man, you could probably get one for $150, $200. Of course, look up the reviews, make sure it's a good one. It's a nightmare if it's not, so make sure it is a good one. Of course, again, if you're new, you don't really want to be getting a super legit $1,000, $2,000 one. But these things can get huge. You can get room size printers, meter by a meter. I think even larger prints. It's getting to the point where I think everything will just be 3D printed in the future. You want a vehicle, you'll 3D print it. And if you're a technologically advanced person, you'll just be buying designs or designing stuff yourself. You won't be buying a car, you'll just be printing it. You won't be buying a bicycle, you'll just be printing it, Who knows? I'm sure, or it'll be a lot cheaper to do so. I'm sure not everyone will want to have to print, their own stuff. The same way nowadays, not everyone wants to make their own stuff, which is why you're able to buy stuff, and we have shops. But especially for the people who are more creative and more interested in this type of stuff, I think it's very, very fun and very, very good. It is an advancement of technology. You get it and you'll be like, wow, this is the next level. This is it's virtual reality or AI, 3D printing. These things are all smartphones back in the day, 10 years or more than 10 years ago now, I think. Actually, nearly 20 years ago. Is it? Was it 2006? Let me just look this up. First iPhone. 2007. Which is nearly 20 years ago. That's insane. That is actually insane. So anyway, a lot of fun. Of course, check the links in the description, and Search for commercial stuff and have a nice day.